calibrate your approach, optimize your costs, get the best benefit for the tools that you're buying and deploying on your system.
Welcome everyone to the Industrial Security Podcast. My name's Nate Nelson. I'm here as usual with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions. He's going to introduce the subject and the guest of today's show. Andrew, how's it going?
I'm very well, thank you, Nate. Our guest today is Alexandru Suditu. He is the General Manager at Enevo CyberSec, which is the cybersecurity division of the Enevo Group, which is a large automation and control company. We're going to be talking about sort of covering all the bases, the breadth of industrial security. We're going to touch on network hardening and monitoring and penetration testing and recovery and sort of the big picture of everything you have to do.
All right, then let's jump right into it.
Hello, Alex, and thank you for joining us. Before we start, can you say maybe a few words about yourself and about the good work that you're doing at Enevo?
Andrew, first of all, thank you for having me. Right now, I'm General Manager of Enevo CyberSec, which is the cybersecurity division of Enevo Group, a company that does an engineering company that does automation and control, with a specific focus on the energy sector and oil and gas. At my background, I come from designing the ITC and cybersecurity part of industrial control systems. Just a couple of reference projects in Greenfield. We've designed 2 hydropower plants in Romania. This was the whole automation done from scratch, and I was involved in designing the IT part and the cybersecurity part for brownfield rehabilitation of critical system hydropower plant. Recently completed a full cybersecurity assessment for a transmission system operator, which involved, besides looking at the controls, doing risk assessment, penetration testing on the public exposure for critical services, bridges between IT, OT, looking for indicators of compromise within the utility network, and doing hands-on assessment of substations, redoing the as-built network diagram, network exposure of devices, and kind of wrapping everything up with a 3-year transformation program of the main projects that any industrial control system owner should jumpstart in order to get to reach a proactive level of monitoring on his facilities.
You're going to touch on a bunch of different topics. Let's start with hardening, if we can. What is host hardening, network hardening, and how is it different in the industrial space than in the IT world that we might all be a little more familiar with?
I'm not going to go into the nitty-gritty details of how we do hardening on typical operating systems or on the network side, where you do the segmentation part. You need some VLANs, you need some filtering and limitation of what ports are communicating, what protocols are allowed. I just want to touch on the complicated stuff of doing hardening for industrial control systems. What I mean by this, the whole automation side, right, is focused on a specific industrial process and ensuring that that process works. When you do the commissioning for the control part of a substation, take for example, that is signed off by the automation company, vendors, everyone, that it will govern that process according to the specifications. When you want to do hardening on that, you need to do some changes. Now, those changes might or might not impact on the process that it's governing. And all of a sudden you have a problem of someone needs to take responsibility for all the changes being performed on an automation process. And the issue here is that most of the cybersecurity companies usually come with an IT mentality. Not an IT mentality, that's not necessarily the issue. But when you need to touch it from both sides, because you have the cybersecurity expertise of what needs to be actually hardened, but you also need to cover it from the engineering part and making sure that every change that you're doing is not going to impact the process that is being governed.
It makes sense in general. Do you have a specific example or two for us?
Very basic example. You have some issues, some vulnerabilities that were discovered on a PLC, and you want to do hardening of that device by patching it. Patching a PLC usually involves a firmware upgrade. Now, that is a major change on a PLC. You need to have the code run again, recheck it, revalidate it, that on the new firmware version, there is no impact to the functionality of the PLC within the process. Same goes, for example, if you're doing code review of a PLC and you notice that some sections of the code might be exploited in a way or another. And if you want to do the hardening there, you basically are doing modifications on the code governing the industrial process. So always you need a process engineer with you. You need someone who is familiar with the process and can retest the whole functionality again, because you have dependencies, right? Even if you touch on just a little bit of the system, you need to ensure that all the other bits and pieces are running accordingly. Just take, for example, the SCADA system, the main system that monitors and controls the infrastructure. You got to make sure that data is still being sent there. You don't have any connectivity issues whatsoever.
So that was Alexandru, touching on some of the challenges in updating, updating PLCs and keeping them hardened in the sense of patched. We're about to switch gears into monitoring.
Hold on, Andrew. Before we switch any gears, I'm a bit confused. What is the through line of this discussion here? What is the theme, so I could keep track?
Well, Alexandru is an engineer. And the theme that I pulled out of the discussion here is, he's going to be talking about the engineering perspective on cybersecurity. What it takes to try to add some security value into a complicated, industrial automation process. What it takes to keep everything running in the course of trying to add that value. Doing security without messing anything up. So let's go back to Alexandru. He's switching gears to monitoring, and he's going to be talking about, tuning the security monitoring system for the specifics of the industrial process. So another topic that you wanted to touch on was monitoring in the industrial space. What does monitoring mean to you, and how do you do it? What are the issues?
So the main objective of monitoring is to gain visibility within the system that you are protecting, right? And here you have a couple of, not say the challenges, but you have a wide range of tools that you can use to deploy to do monitoring of ICS environments. You have IDS tools that do deep packet inspection, look within the traffic for specific patterns, can look at commands being issued, value within the commands. You have visibility within the traffic. You can use endpoint detection and response to have visibility on the operating systems and ensure that the operating system processes are running okay. There is no malware abuse or no abuse of those happening over there. The key trick here to have proper monitoring, what I mean by proper monitoring is to have all these tools calibrated at the right level to look at the specifics of that process. Because each process has its Achilles heel, let's say, some specific things that you can do to them and shut them down for good or create physical damage. So our approach and our belief is that all these tools that you deploy to gain monitoring, it needs to also be calibrated to the specifics of the process. Just a simple example of this If we're looking at an idea solution and we're seeing the commands being sent and we see the values, we need to put specific alerts in place for certain thresholds of those values that we know will impact that process.
Okay, so can you talk to me more about calibration? I mean, it's one thing to say I'm going into a substation where there's one RTU and a dozen protective relays, each of which have maybe a dozen registers that can be written to. We're talking less than 100 registers in a substation. We're talking maybe 50 or 75 substations. That's a kind of, and a lot of it's repetitive, I imagine. That's a degree of calibration that, kind of makes sense. But if we're talking about, a hydro plant or any kind of power plant, in my understanding, you might have, 10 or 20,000 sensors and actuators on a single generating unit. You might have 5 generating units in the power plant. That scales up to, we're talking, maybe 50, maybe 100,000 things to calibrate. What do you do in power plants? Do you really scale that big?
You're spot on indeed. If we're looking at a hydropower plant, for example, you have tens of thousands of set points, values that are being exchanged constantly to govern that process. We look at the critical ones that we know will lead to a full stop of the process or can cause physical damage to that process. So you don't monitor all of them. That would be insane, too much work. But you can look at the most critical ones that that if someone would want to do an attack, those are the values that they would trigger or set to abnormal levels. Just as an example, even if you look at one of the first cyber attacks on ICS at Stuxnet, right? You had the centrifuges that were set to a RPM higher than normal for the process, leading to the malfunction and damage. So that would be an example of a critical value that you would look at. The RPM of the turbine itself, at which value it was set.
So as a general rule, is it fair to say that you would focus, maybe not exclusively, but certainly intensely on protective relays and their settings? Is that fair?
Oh, for sure. If we're talking about the substation level, protection relays are the key part in ensuring the safety of that process. And here, you also have the issue of goose messages that need to be under 15 milliseconds to ensure that they can decouple from the line in safe conditions. And those are layer 2 and need to go unfiltered. So it's really important to see for specific values on 61850, if they're being set on the network or exchanged on the network. With 61850, you have the specific part that it's dependent on the SCL file diagram of the substation. So when you are designing the protection scheme of a substation, it's in general similar across substations, but they are very unique and customized to each of them, right? And when you're doing monitoring of values on 61850, you need to have those being tweaked and calibrated again to the uniqueness of that substation and that specific protection relay.
Did you know that power plants are exempt from 1/4 of NERC-CIP requirements when those plants use Waterfall's unidirectional security gateways? NERC-CIP does not demand that power plants use the gateways, but the regulations recognize the strength of unidirectional protections. The regulations reward sites who use gateways by dramatically reducing the number of security rules for those plants. For details on the exemptions, please download Waterfall's latest report on the NERC-CIP standards. You can find the report on the waterfall-security.com website in the Resources tab under eBooks and White Papers.
Andrew, in the course of those few questions and answers, I heard a lot of buzzwords. Maybe you could help me out with some of the content we just went over.
Let's start at the top. Remind you and everyone listening about substations. These are generally high voltage, small installations that convert voltage from one voltage to another because it's most efficient to transmit power through the power grid at very high voltages. The key part of the substation is therefore a transformer that changes the voltage. Sometimes there's capacitors involved as well. And protective relays are the devices in the substation that protect the transformers, that prevent damage to these very expensive, very difficult to replace components. These are, the relays are specialized computers. They do only one thing. They detect, let's say, lightning strikes or, other faults in the power system, and they act. They trip breakers. They interrupt power flows to prevent damage to the substations. So in that context, 61850 is a newish. I mean, the industry's been around for most of a century. It's a newish family of communication standards for automation in substations. Goose is one of those 61850 standards. Goose is something that is sort of local to the substation. Goose is nothing like the Internet protocol. And now, Goose does use Ethernet networks, but it uses Ethernet broadcasts. I'm weak on the details, but I have the impression that pretty much every device, most devices, every device in the substation sends out an Ethernet broadcast packet about the status of the device, at least every 10 milliseconds. Every device in the substation sees all of these broadcasts and can use whatever information is relevant to the device to do the protection of the substation and other control functions. SCL is Substation Configuration Language. This is a way to express how the substation is protected. You express protection schemes in this language. The piece of that I've been involved with, in terms of protection schemes, and I'm not an electrical engineer, I'm a cyber guy. The piece I've been involved with is, how do you reset the relays? How do you re-enable? When is it safe to re-enable power flows after a trip, after a lightning strike, after a tree hits a line, after whatever? And sometimes you do this because, if the relay says, there's a problem, it trips the breaker, it interrupts the flow of power. Sometimes the protection scheme says the relay remains in a tripped state until it gets a command saying all clear. So the relay tells the breaker, interrupt the power constantly. It sends a constant signal to the breaker until it gets a reset command. In other protection schemes, the relay, whenever it senses a fault, will send a command to the breaker, yes, interrupt the power flow, but then as soon as the relay stops sensing the fault, as soon as the fault condition disappears, let's say the overvoltage, well, you interrupt the power, the condition disappears, the relay goes back saying, that's okay, turn the power on. I'm in a good condition. But you want some human oversight here, or at least automation oversight. And so somebody else will go and manually send a signal, not to the relay to reset, but send a signal to the breaker to reset. It all sounds like, I don't know, counting angels on the head of a pin, but exactly how the protection scheme works varies from operator to operator. Sometimes it varies from substation to substation. So understanding the protection scheme at a very detailed level is very important. And the whole point we're coming to here is monitoring and calibration. And, the point here is that, if you're monitoring what's happening in the substation, a lot, some of the most important stuff that's happening in there is protecting the protective relays. And so you need to tell the monitoring system exactly what's normal, exactly what's not, so that, whenever the monitoring system sees a command come by that seems to contradict the configuration of the substation in that substation's, substation configuration language, that contradicts the details of the protection scheme. That's what has to be called out as suspicious and potentially an attack. So there's, I guess one of the challenges in doing industrial monitoring is if you want to do it right, there's a lot of detail there. And you were going to talk to us about penetration testing as well. How does penetration testing fit with all of this hardening and monitoring stuff?
They have the same base in the sense that you need a replica of your environment, not necessarily a full-scale replica, but the key parts of it. Looking at a substation, you would need to have the SCADA system that is controlling and monitoring the entire process. You need to have an engineering workstation and a couple of protection relays, because in a typical substation, they would be of the same vendor and same firmware version as it was set when the commissioning was done, with small tweaks, what changes happen in the meantime. So, if you want to do hardening, basically do changes on a system, you need to have a small test environment. If you would like to do any sort of red teaming activity, if you want to exploit a vulnerability on the firmware, you would also, in a pen test environment, you would also need a replica. So this is kind of how they both connect. You have to have this component of testing out the changes or the exploitation of the vulnerability itself.
I see a theme here where you're talking about using a test bed to test your hardening. You're looking at doing your penetration testing on the test bed to make sure that your hardening worked. It sounds like the test bed is sort of a common theme here. Is that right?
That is very spot on. If we look at the enterprise environment, you usually have this universal acceptance testing site where you make sure everything is running smoothly before it goes on out into production. It's vital for the utility part, for the industrial control part, to have this test bed where you do any training activities, get your staff familiarized with the tools that you have deployed over there, and as mentioned, test any changes done to the system before applying them into production during a shutdown window, or even if you want to do a pen test, in what sense, to, let's say, validate that certain vulnerabilities are exploitable within your systems, or to get a better understanding of the impact of that vulnerability within your system.
Test beds are important. I get that. But can we talk about cost? I mean, it's one thing to say, I'm going to model, I've got 50 substations. I'm going to buy a few extra, protective relays and an extra RTU. And that's my substation test bed. With a power plant, if you want to have a test bed, you're going to need to have another copy of the DCS. And PLCs and whatnot. Can you talk about cost? I mean, I've had people call me up and say, Andrew, I read your book, test beds are important, but do you know what it's going to cost me to buy another DCS license? How do you do this in sort of the big iron? How do people manage the cost?
That's a very good question, and it's all about using the right tools for the right job. What I mean by this, you don't necessarily need to buy a full-blown license, because you're looking at testing a specific thing when you're doing the red team activity or when you're doing the hardening. So you can use not a test license, but have them run in trial mode. And they have most software applications, they have a certain window in which they can run for a short amount of time, and then they just close. So you can't use them in production, but you can use them enough to test the specific vulnerability or specific hardening activity that you want to deploy.
Now, Nate, Alexandru's answer there, use a test or a demo license. I don't know. To me, that's brilliant. I mean, I don't know why I didn't think of that 2 years ago when the gentleman asked me about buying another DCS. Now, in my understanding, it doesn't always work. Not every DCS has a test mode or a development mode, but I know a lot of them do. And even the ones that don't, I imagine that you can make the case for deeper discounts from your vendor if it's for a test bed license rather than a production license. And while we're on the topic of test beds, I was chatting with Alexandru about this, before the show. He mentioned that he's not directly involved with it, but he said, look, these test beds, IT people are getting more and more involved with these test beds. They're primarily an engineering test bed, but in the world of supply chain, I mean, we trust our vendors. Should we trust their security updates? In the world of supply chain breaches, the IT people are starting to look hard at these test beds as tools to use to, test incoming security updates or even new software versions for malware. I mean, does ransomware leap out of the thing and infect the whole test bed? That's sort of a clue. Or more subtle. Does the new software beacon home to hackersorus.com? Again, do other sort of suspicious things that control system software shouldn't be doing. So test beds are important, and the comment on how to get one, that it doesn't have to be running continuously. You can use these demo mode licenses. Is a way for all of us to afford more of these useful tools. And you guys are focused on the electric sector. Can you talk about, in your experience, in your part of the world, can you talk about the state of the practice? How are we doing security-wise?
It depends a lot on the scale of the utility. Because if you're looking at the big companies in the industry, they tend to be rather mature, more experienced in the game, have more tools, more experience as a whole. But if you look at the smaller players, which again are critical or just as critical for the well-being of a country, they don't have that much internal knowledge. And again, that's something that we can help them with as a company. But I feel that they also are the ones who are doing the request for the projects, right? Writing the scope of works. And usually they're mimicking or imitating what they've seen at the big fish. But what they don't know is how those approaches or specific approaches done by these big companies failed. And this is something that I feel it's an interesting challenge for the industry, for the cybersecurity industry, for ICS, to talk about the failures, the dead ends, the investments that didn't necessarily pay up and wouldn't recommend another company pursuing.
Andrew, it seems to me that Alexandru sort of changed his tone a bit there, right? We're talking now about failures, about what we're getting wrong. It seems to me like something in his voice has changed a little bit. Maybe I've glossed over a particular important insight here.
It is an important insight. This is one of the sort of the when I record these episodes, I always look for something bluntly that I can learn too. And this is something I learned. The point he made was that a lot of organizations, in the electric sector, large and small, outsource, some or all of certain parts of their engineering. And one of the mistakes that he sees the small fry, the smaller organizations, mostly distribution organizations, I imagine, the smaller organizations making, is that they look at the proposals, the requests for, the RFPs, the RFQs, requests for proposals, requests for quotes that are issued by the big utilities. And they look at those proposals and say, these big utilities are doing this. It must be a good thing to do. And they put out similar proposals, not realizing that there were problems with the original proposals, that these projects actually failed, or they cost much more than was expected because there was problems with the proposal. So understanding, failures and, having the experience of an engineering team, like Enevo, at your disposal. This is important when you're putting your own proposals together. I mean, in my own recollection, I remember back in the day, I was helping to sell intrusion detection systems, and a problem that this was very early days, a problem that sort of the industry didn't really appreciate, was that when you put these intrusion detection systems and these SEMS, security information and event management systems in, you're giving security analysts the tools to see what's going on in the industrial system. And, the feedback I got after deploying a bunch of these from, a particularly insightful customer was, Andrew, you need to know a lot to be able to use your tool. And I'm going, what do you mean? Our tool is easy to use. We have a very easy user interface. He says, no. He says, you got to understand what these alerts mean. This registry value changed. That should never change. It's in a section of the Windows registry that never changes. It changed. What does that mean? I don't know. What does that value mean? There's hundreds of thousands of values in the registry. What's that particular one mean? You need a lot of knowledge. And, if you put out a proposal as a small organization saying, we want a SOC, we want some intrusion detection, you might not realize that these projects have failed, that, the big utilities have spent 3 times as much as they thought they were going to, because they had to train their people. They had to hire people who understood what this stuff meant. There was more to it than was evident in the original RFP. So, not just looking at what the big fish are doing, but looking at someone who's got some insight into whether it worked and whether it makes sense for a smaller utility to do that. That's important to do. Well, Alex, this has been great. Thank you for joining us. Before we let you go, is there a thought you'd like to leave with our listeners?
The main thought would be to have an integrated approach. Keep in mind that you need to, besides monitor for the security events happening on the OT side, you need to do hardening. You also need to do testing the vulnerabilities to identify the key risks that you need to be addressing, so to calibrate your approach, optimize your costs, get the best benefit for the tools that you're buying and deploying on your system. And please feel free to reach out on LinkedIn, and if you have any questions or want to chat about the topic, more than happy to offer our support.
Andrew, how about a last word to sort of draw us out here?
Well, my big takeaway is I like the idea of sharing information about failures. I mean, I go to a lot of conferences. At these conferences, you hear people boast about their successes. Nobody talks about their failures. And, in the electric sector, Alexandru pointed out that, Enevo has this knowledge. You can tap them for it, but sort of more generally cross industry, I wish there were a forum for talking about failures, because, arguably understanding failures is as important as understanding successes.
Okay, then with that, thanks to Alexandru Suditu for speaking with you, Andrew. And as always, Andrew, thank you for speaking with me.
It's always a pleasure, Nate. Thank you so much.
This has been the Industrial Security Podcast from Waterfall. Thanks to everybody out there listening.